All right, so welcome back. So hopefully everybody at least has a good rest during the reading week. So we have done the first half of the course, and then I will give you a very quick roadmap about what we're gonna do for the second half of the course. Things will get a little bit more intense now that we have covered definitely the basics and also exception, J units, and also half of the story of the EECS. So let's look at the semester calendar. But before that, quick reminder. So we have the notes template and also office hour. They will be the same, consistent. The new feature, digests, just in case you haven't got a chance to look into it, I'll show you very briefly. It's really the resource made available to you. I'll give you some advice on how you may want to make use of them, especially for written test and also the final exam. It's definitely going to help. I'll give you some advice. I'll keep bugging you about how useful it could be. Okay? And then your lab number 2 will be due Wednesday, tomorrow. Please make sure you submit your best attempt. It's going to impact your programming test number 2, which will be July 6th. I'll show you on the calendar. And also next Monday, of course, will be your written test 1. I may not be able to make it to Wednesday, but since I promised to you guys, I will make at least 1 hour available to you on Friday. I'll need to confirm. Either I can make it more like a Q&A session. I can answer your questions about the topics related to written test 1, or it could be just like an office hour over Zoom, so you don't need to commute, right? I'll reach out to you, definitely. It's something I promise. I'll keep that, okay? Let's look at the semester calendar very quickly, and then we'll move on, okay? Okay, so if we look at the semester calendar right here, so now we are back, lecture number 13. So my plan will be I will finish most of the equals method, especially phase number 3 and 4. So before the reading week, we have done phase 1 and 2. You haven't got a chance to catch up with the lecture, please do so. It's going to be beneficial, especially for next Monday, of course, for written test 1. So whatever we cover today, I will confirm which part will be covered next Monday. But whatever we cover on Thursday, it will not be covered on written test 1. Okay, I will confirm explicitly. So lecture 13 and 14 this week, we're going to do equals method. And then next week, starting from Tuesday, I'll give you guys maybe some little exercise to try it out. You can do whatever you like. I'll give you some guidance, right? I'll reach out. Starting from lecture 15, we should start talking about inheritance. It's going to be the biggest topic for this course. Since we talk about advanced OOP for the course, you have to learn about polymorphism, dynamic binding, polymorphic collection, typecasting, etc. I'm going to tell you this whole story systematically. So we're going to enjoy the whole journey. It's going to be intense. It's going to be challenging, especially you haven't seen inheritance before, but I'm quite confident, right? If you just follow along the lecture, you should be okay. Anyway, so we're going to spend at least 6 to 7 lectures on inheritance. This is a lot to talk about. And then I'm hoping lecture 22 or lecture 23, the latest. I'll try to make it maybe lecture 22, so I can give you some assigned exercises beforehand. So we should really spend about 2 or 3 lectures in the finals towards the end to talk about recursion. So that one there, I'm not going to talk about something too advanced. It will be the job for 2101, the data structure course. What I want to do is talk about the general design principle, walk through some examples, and also give you some guidance about how you should really get prepared programmatically and also for the exam. I'll give you explicit hints. Okay, that one I can give to you. Okay. And then for the exam over here, it's going to be just one single week from August 6th to August 13th. I don't think the official schedule has been out just yet, so I have no idea. As soon as I know, I can maybe mention to you informally. Sometimes they might let me know like a few days before you guys will know from the registered website. If I know it, I'll definitely let you know informally. Okay? But please don't make any travel plan around the exam. There's no way I can accommodate for travel plan. Okay? Okay, and your programming test 1, we started the grading process. It has been a little bit delayed during the reading week, but I'll try to get it done as soon as possible. May not be exactly in time for your written test 1, but definitely early next week. I'll make the feedback to you. You can also speak to me about your test during the office hour. Okay. Let me show you also quickly about lecture digest. Okay, it's a new feature. Of course, it's kind of optional, but I will really encourage you to give it a try, right? So you can now assume for every lecture, let me take the last lecture, okay? Lecture number 12, right before the reading week, right? You can see the topics over here on the lecture side. You got recording. Of course, you only look at that if necessary. And you got notes template. You got the annotated notes. You also got the lecture digest over here, like a compass, right? So if you click on that, it's going to be like a PDF document, well formatted, and that one there is not supposed to give you like a duplicate of what's happening in the lecture. Not really, it's not a goal, right? I don't want to increase your workload that way. That one is there is really to highlight about what we talk about in the class. What's the important concept we cover, and also what's the key terms, and what's the common misconception, what's the clarification you should really look into. And also suggested some practice as well. So this document here is really based on the lecture material specifically for that lecture. I'll try to make it available just around the time I made the recording available. I would say every digest for each lecture will be about 8 to 9 pages, sometimes it could be 10. If you really don't have the time to read the whole thing, I would suggest at least look at the section there, right? So look at which section might be better for your learning. It's really creative for you, right? So let me just talk about here very quickly, right? So we talk about section like a main idea, the roadmap, also key terms, notation, and also key example. So the key example here doesn't really duplicate the tracing again, just kind of give you the highlights about what we're supposed to trace in that particular example. Common pitfalls, misconception, and like a learning outcome, what you're supposed to really have to achieve in that lecture. If you find any gap, that might be something you can do to fill the gap. And also suggested practice. It's kind of based on what I said in the lecture and also based on the material. And then just give you some about where to review and also reminder, okay? So it's a nice document, you know, you can maybe try to think about how you may want to mix it into your study habits. I'll leave it to you. If you want to speak about how exactly you can use the digest, I'm happy to talk, right? It's really resources created for you guys, okay? Especially, I would suggest if you find it too much for the upcoming written test one, you may want to start using it for studying for your exam. It's going to be a big help. I cannot emphasize more, okay? If you want to talk about the digest, or any feedback you want to give to me, I'll be more than happy to talk, right? Let me know, okay? All right, so that's about, and we also got your written test one next Monday, of course. And of course, that one day you need your mobile phone. I'll send you a reminder, right? For written test, we're gonna do over E-class. And your programming test number 2 will be the week after. Of course, we cannot give you the programming test 2 result before the drop deadline. It's on the same day, right? We're gonna announce that in the beginning. So hopefully, if you have to make a decision, what we will have done by July 6th will be enough for you to make a decision. Of course, in general, I hope everybody to stay. Okay. All right, so that's about what I would like to say before we dive into the materials. Guys, any questions? All right, we got 6 more weeks for the course, and things will get more and more challenging, but I think intellectually it's going to be more interesting. I'm excited about it, especially the inheritance part. Okay. But for today, I would like to start with phase number 3 for the equals method. It's going to be your object equality lecture slides and slide number 17, right? I'm not going to read off the slides, so I just want to mention to you, you want to study this slide here, right? For phase number 3 and phase number 4, all right? Especially what we're going to look at. I'll make it a little bit larger, okay? You will see things like get class. What does it really do? And also, you can see we got parentheses and then put some class name inside parentheses. It's something called typecasting, right? We're going to see why we should do it. And also, why can we not simply say obj dot x right here, rather than other.x? That will be the kind of question we want to answer, right? But before that, I'll rather give you a very quick tutorial about certain relevant terms. Let's start with that, okay? You will see the relevant terms as well on the slide, like a static type, dynamic type, etc., like in typecasting. But you can read the slides. Let me just go directly to a small example. So today, we're going to focus on talking about static type, dynamic type, and also typecasting. So these are all relevant for your understanding of phase number 3 and phase number 4. So since we haven't really officially started the discussion about inheritance, I'll try to restrict this example here only to the object class and any class where you want to override the equals method. We're not talking about inheritance in general, not yet, okay? So for this one here, it should be, contained enough for you to understand, okay? But today is going to be very important. I don't mind going very slow, but if you really got any point, you really got confused, do let me know, okay? We need to clarify, okay? Let's now go for it. Let's now go over definition for static type, dynamic type, and typecasting. Let's start with static type. Okay? By definition, it is the declared type. Very simple definition. Okay? Let's write it down. For static type, is whatever type you declare the variable to be. And it cannot be changed. Once it's declared, it's fixed. It's also called the declared type. For example, you can see O1 here is declared of type C1. O2 over here is declared C2. And O3 here is declared objects. So they have different static types. That's all you need to know, right? Static type. That's how you look for the static type for a particular variable. Just go back to the declaration for that particular variable. All right, so this declared type is always fixed. So that's easy to identify what the declared type or static type is for a variable. But what is so important about the declared type? So here it comes, right? So the static type is going to define or determine the range of methods you can call on that particular variable. Let me write down these important highlights, and then I'll show it to you right away. Okay? And this insight here is also something we have to repeat over and over when we get to inheritance. So the declared type is going to determine determines the range of methods that can be invoked on a reference variable. We're not talking about integer, we're not talking about Boolean, just some type like objects or any class you actually have in the scope. All right? So the range of methods. Let's now see some example right away, right? This is all to do with compilation. So when I say determines, so this is how the compiler of Eclipse determines behind the scene whether or not a line of Java code of this sort should really compile, right? So this is to do with compilation. Let me also write it down. It's to do with compilation. Let's now see some little bit restricted example here to see before we come back to the code. Let's say here, we have the object class, which we know exists in the Java library. Let's say we also got two classes. Let's say we got C1 and C2. Let's be clear here. So class C1, very simple. It has only one method called M1. And class C2 has only one method called M2. So C2 does not have M1. And also C1 does not have M2, right? It's clear, right? Just have each of the classes actually got just one method, okay? With that set up, let's see a little bit about inheritance hierarchy, just for this restricted example. And from the lecture number 12, right, before the reading week, we said the object class is the parent class of every class, meaning that every method in the object class will be accumulated or inherited to every class you declare. If you declare vaccination, your lab number 2, definitely you got all the methods from the object class. But let's now talk about this particular setup. Let's put the object class at the top. Okay, object class right here. And let's focus on just the equals method, where the equals method has just a default definition, like a this equals obj, right? That's the phase number 1 and 2 we spoke about in lecture number 12. And we have two classes, right? We talk about C1 and C2. So we got C1 over here, and also we got C2 over here, right? And by definition, every class is a subclass of objects. So let's draw the arrow. Okay, so C1 implicitly we say extends. We'll talk about the extends keyword next week when we actually introduce how you can do inheritance in Java. But think about it extends implicitly. You never need to write a line like that. And also C2 is a subclass of objects. And we know that in C1 we have a method called M1. In C2 we have a method called M2. So let's put them down. So in C1 we got M1. In C2, we got M2, right? That's a good setup. All right. And why do I say accumulates? Every time you want to see what a particular type is going to support a range of methods to be called, you have to think about all the parents, or we're going to talk about ancestor, but let's not worry about ancestor. In this case, if I want to figure out what kind of method can I call on a static type of C1, M1 for sure, because M1 is there. But at the same time, you want to look at the parents of C1. By default, it's going to be object class, which will accumulate equals. So think about, it will be as if we also got equals method right here. So this is exactly inherited from objects. Similarly, the M2, in C2, we also inherit the equals method. Similarly, okay? Of course, the equals method here depends on what you want to do. You may just want to use a default version without overriding it, or you may decide to override it, right? It's a separate issue. But for sure, for C1 and C2, you can definitely have equals method as part of the with that expectation. Let's now write it down here. Let's have a table over here. Okay? Let me recreate the declaration here. We got C1, C2, and also objects, O1, O2, and O3, right? Let me just put them down in that page. So let's put it here. So C1, O1, C2, O2, and also objects, O3, right? Let me just double check. C1, O1, C2, O2, object O3, right? So these are the declaration. We're only talking about compilation, so let's not worry about whether it's going to point to some object just yet. Not yet. All right. So let's now look at the variables. So for the variables, we have we got O1, also we got O2, and also we got O3. And let's figure out what will be the static type of each one of them. Static type. And sometimes I might just say ST for static type, right? Just for short. And that should be obvious. For O1, it should be C1. For O2, it should be C2. And for O3, it should be objects. Again, the definition is simple. Whatever declared type it is for the variable. Once it's declared, you can never change it. Fixed. Okay? Now, let's go to the next column. So this is something I call expectation. I think that's the most intuitive way for us to understand. If you declare O1, for example, to be of type C1, later on in the code, okay, later on in the code, right? Let me put a star over here, okay? Put a star here, so I'm going to continue from here. So here, starting from the start, we assume we already got C1, O1, C2, O2, and object O3. Now let's talk about method call. I may write something like, I might say O1 dot M1, O1 dot M2, O1 dot equals, right? And let's enumerate all the possibility. Okay, over here. Let me just make it a little bit smaller, all right? And then we're gonna look at all of them. The context object can be O1. And the context object can also be O2. And it can also be O3 as well. Okay, O1, O2. Okay, finally, I'm running out of space. I'll just put it aside. Okay, right here. Okay, that's a third block. And here it will be O3. Let's say I put all these 9 method calls in Eclipse. Some of them will pass the compilation. Some of them is going to show you some compilation error. So at this stage, we need to understand how to figure out. It's all to do with expectation. Okay? Let's now look at this part over here. When the context object is all to do with O1, right here. And we know the static type is C1. And from the diagram, we know that M1 is declared in C1. Also, C1 inherits the equals method from objects. So there should be exactly two methods we can call, which will be M1 and equals. That will be the complete list of methods you can call. So I'm going to put equals for sure, and also M1. So this part here is called the expectation. If you're calling any method outside the expectation of the static type, there will be a compilation error. Not exception, compilation error. All right? So let's look at here. O1.M1. M1 is within the expectation. So this method call here, check. And then O1.M2. M2 is outside the expectation. Does not compile. And if I look at here, O1.equals, should this compile? It should, even though equals method may not be explicitly declared in C1. It's possible, but it will be inherited from object, so it will be within the expectation. All right? So this is also fine. Take 1 minute. What about the remaining 6 lines? Think about, should each one of them compile or not compile? And then we'll go over that. Okay, one annotation I will just make it to help you over here. Think about O2 over here has a static type C2 because we can see C2, O2 right here. And also for O3, the static type is objects because we said objects, O3. All right. Should O2.M1 compile? No, because O2 has a static type C2, and C2 here has the expectation M2 and equals. These are the only two, right? Let's write it down here. So it will be equals and M2. And also for objects, it's a static type. It should be just the equals. It makes sense. As far as we are concerned, object only had the equals method. M1 and M2, nothing to do with the object itself. It's only for the later subclasses that declare the M1 and M2. So here, would you agree? So here should be no, right? Because M1 is outside at the expectation for C2, right? But it would be okay to say O2.M2. That'll be fine. Can we say O2.equals? Yes, right? Okay, all good. Okay, and final 3 lines. Can we say O3.M1? No. Because O3 static type objects which only expect equals. That's the only one. Okay. So accordingly, so equals is okay, but if you try to call M1, M2, no good. That's all you need to know about static types. 2 things. Number 1, how can you look up the static type for a variable? Look at where you declare that particular variable, and then that class will be the static type. Once you declare that static type, once you identify the static type, think about what methods will be available in that particular class. It will be whatever methods you explicitly declare in that particular class, plus whatever that's in the parent class that will be inherited. In this case, we only assume only the object class. Later on, we're going to see there could be like a hierarchy where you have to accumulate the methods in a more sophisticated way. But don't worry, we'll get there. Guys, any questions about static type? Okay? Okay, good. That's about static type. And then, so now it should be okay. Let me just do a little bit more quick annotation. So now if we look at many lines in this particular example here, we should be good. Okay. First of all, we have C101, C202, declaration, and objects O3. So these define the static type. And we know that O1.M1 is fine, and O2.M2 is also fine, right? The same, right? We already explained it in the page, right? I just want to move ahead, right? I'll get to the new keyword in just 1 moment. Let me just talk about what we already know. And then when we actually look at the method call here, so when you say O3.M1, O3.M2, because we got object as a static type, so both of them will not compile. That's all we know so far. no, and no, okay? Because of the expectation, right? Any questions so far? We're good? And then let's now move on to dynamic type, okay? What's really dynamic type? Dynamic type. Dynamic in the sense that it's not fixed. It may be reassigned or it might change whenever you do any variable reassignments or when you do the initialization, okay? So dynamic type may be changed. May be changed at runtime for as many times as you like. At runtime. And what's the role that dynamic type is going to play? Okay, it's going to somehow say, if I have a method call, I know that it compiles. It's within the expectation of the static type as we said so far. And then when you try to make that particular method call, it's going to tell you which version of the method is going to invoke. Right? So this is, again, a very tricky concept, but I would say within this contained example, it's still okay, manageable. We'll get to the more sophisticated setting once we get to inheritance. But I'll write it down. Determines the version of method that's to be invoked. Okay? In this particular example over here, you can think about M1 and M2. There's only one version. That's okay. When there's only one version, you just call that version. But in general, there could be multiple versions of the same method when you try to do overriding, in which case you have to know which version to choose. All right? I'll get to that a little bit in more detail. Okay? How do we judge the dynamic type? Whenever you visualize the objects, remember, let's say I got some reference variable, like a ref over here. It points to some box of the object, and we put some title over here. The title over here is the dynamic type. Okay? That's how you tell it, how you trace it. But let's see, example. Okay? Let's now trace these two lines. Okay? What we have is, we have O1. We have O1 that points to some C1 objects, right? And there's no attribute, let's say, just have the box. And then we have C1. And also here we got O2 that points to an object of type C2, C1 and C2, all right? Right here. C1 and C2, okay? At the moment, C1 is the dynamic type of O1 at this point, because O1 stores the reference of a C1 object. The static type and dynamic type sometimes might be the same, but they don't need to be the same in general. We'll see example very soon. Okay? And then the C2 over here is set to be the dynamic type of O2. And if you like, you can also make your diagram a little bit more detailed. You can say O1 was declared to be C1. O2 was declared to be C2. So I can put C1 over here and also C2 over here. All right, that's how we visualize. So now we are distinguishing between static type and also dynamic type. Okay? And you can think about, for example, when I say O1.M1, I'm actually calling O1.M1. Which version of M1 am I going to call? There's only one version. So just go to C1, the dynamic type, and then call the M1 right there. Okay, just one version. Okay, nothing tricky. And let's now look at this line over here. All right, objects. Okay, so what we have is, let's declare that first. So we have object as the static type right here. Okay, and then we actually got O3. Okay, so think about O3 has a static type object, never changes. Okay, you can think about initially there's no dynamic type because it's just pointing to null, undefined. And then we're going to look at two variable assignments. line, let me just choose the right color. Just beg your pardon. Give me one moment. There we go. We say O3 equals O1. And also O3 equals O2. Okay? Let's assume for now, this variable assignment here is valid. Just assume. Okay? All we got to do is to trace it and see what's going to happen. Okay? When I say O3 over here is assigned to O1, what it does is it's going to assign O3 to wherever O1 is pointing to. That's what it does, right? At this point, effectively, O3's dynamic type has been changed to C1. Okay? Because it's pointing to an object of type C1. Okay? And I'm going to look at another line right here. When I see the next line, let me use maybe orange here, purple. When I say O3 is assigned to O2 at this point, right? That means O3, rather than pointing to C1 object here, is going to point to wherever O2 is pointing to. What I have changed was the dynamic type of O3 has become from C1 to C2. So dynamic type can really change. All right? Let's now isolate this transition here and make some detailed notes, right? It's also very important. Static type never require you to trace anything about the code. You just need to look at where the variable is declared. But for dynamic type, you have to trace the code line by line to see how the transition will make. Let's talk about this one, okay? That's something we're also gonna trace very much later, okay? Let's isolate this example here, right? The same piece of code right here, okay? Let's now only look at 3 lines. This line, object O3, and also this line, O3 equals O1, and this line, O3 equals O2. That's all we do, right? We'll look at other parts a little bit later, okay? And by the way, if I want to know what a dynamic type is for a particular variable, the get class that you saw in the slides, I'll show you very quickly. You can see that in phase number 3, we actually use the get class call. It's a library method that's already available in Java. You don't need to define that. That one there is going to give you the exact dynamic type, like the title of the box, like a C1 versus C2. Okay, so that's something you will need in order to understand phase number 3. Okay, okay, we'll come back here. But I'll write a note first. Okay. Whenever I got any objects, and then if I say dot get class, okay, it doesn't take any arguments. It's going to return the dynamic type of that particular objects, right? It's a syntax. So for your lab number 3 that's coming tomorrow, you don't really have to use the get class, except you have to code up that particular phase number 3, which we'll talk about maybe today, right? But we'll see another operator later. Okay, I'll make a note over here. Later, there will be some alternative called instance of operator. Instance of operator. Okay, we'll talk about it. Just want to give you some look ahead, right? All right, let's now trace it, right? What I want to do is I want to draw a table right here. And then I'm going to put labels here. This is line number 1, objects O3, decoration. Line number 2, O3 equals O1 is a reassignment. And number 3, O3 equals O2, another reassignment, okay? So I'm going to say after each line, after the execution of each line, it's going to be 1 and 2 and also 3. And then we're going to keep track of, after each line, what's going to be the static type versus dynamic type for O3. Okay? Static type of O3 versus dynamic type of O3. All right, let's now take a look. So hopefully that'll help you understand a little bit better. Okay? For the column of static type of O3, can we just answer that at one go? We should be able to, right? Because it's fixed. Once you declare, it never changes. So it should be objects throughout. So this part over here, after 1, 2, and 3, doesn't matter. It will just remain to be objects as a static type of O3. So it never changes. Okay. Let's now say after 1, after 2, after 3, what's going to be the dynamic type for O3? After 1, after I just declare the objects of O3, it doesn't store any reference just yet. You just know. There's no dynamic type, right? So here you can say either you can just say null, or you can say it's undefined. Either way is okay. It's undefined simply because it's not pointing to any objects. Okay. So when we actually say 1 here, we basically just got O3, and it simply points to just null. All right, just like that. And what about after 2 over here? When we say O3 equals O1, so that means O3 is going to point to wherever O1 is pointing to, right? So before that, we got O1 and O2, right? Let me just draw them very quickly, O1 and O2, okay? So we got O1 is pointing to some C1 objects. And then we also got O2, that is pointing to some C2 objects, right? That happens before that. So C2, that is pointing to by O2. All right, let's now do line number 2. Line number 2, if I say O3 equals O1, that means O3, rather than pointing to null, is going to point to wherever O1 is pointing to. So that will change the dynamic type into C1. Right? So this will be number 2. Number 3 will be very similar. So when we say O3 equals O2, O3, rather than pointing to here, is going to point to wherever O2 is pointing to. So this will be number 3. That will change the dynamic type from C1 to C2. All right, so that's more like an evolution of the dynamic type. Of course, if your program simply goes on, you can definitely keep changing the dynamic type if you find the need. There's no restriction on how many times you can change the dynamic type. Any questions so far? Yes.
Column number 3, so basically, let's say we're talking in programming perspective.
Yeah.
What we're doing is we're just using object or O3.getClass. Is that what we're doing?
Yes. You can think about, yes, you can say that, for example. Let's say after 1 over here, at this point, if I want to insert a new line right here, if I say O3.getClass, over here, actually it's going to be null pointer exception because O3 is even null, right? Don't try it, right? But we know conceptually it's undefined. But after 2, after we say O3 equals O1, if I say O3.getClass, why don't I insert that, right? I think it's a good question, okay? If I say O3.getClass, that one should really give me C1, all right? And then if I say, after this line here, if I say O3.getClass, you will see C3, C2, beg your pardon, okay? C1 versus C2, yeah. Again, a little bit further look ahead. Lab number 4 is going to be a lab helping you to understand inheritance. That one there, you might find some places where having the get class operator just returning the dynamic type might be useful. You will see that. But the idea would be we want to have the instance of operator ultimately. There's some advantage to it. I'll explain that once we get there. Don't worry about it for now. Okay? So far we got static type, dynamic type, right? All good? Okay. All right, I'm exactly halfway right now. Why don't we take a break? After, let me give you a little bit idea, okay? Well, what I want to talk about after the break goes like this. We understand pretty well about whether a particular line of method call should really compile based on the static type. Also, we can see how the dynamic type of a particular variable like O3 can actually change, right? So far we have seen that. But now, you can see that here. It's a little bit look ahead. Let's say at this point, right here, O3 is really pointing to wherever O2 is pointing to, right? And then you can see that before O2.M2 is okay. However, if we say if we say O3.M2, it is not okay. It doesn't compile. However, they really point to the same objects. Why can we not allow it? That's really some dilemma we are running into, right? So something I'll elaborate a little bit more. That's the trickiest part for this example, in which case we have to see why we can get around with this problem here using typecast. Okay, we'll get there. Okay, why don't we take a short break? You guys can just get your iClicker ready. Okay. All right. Let's now revisit this example here. All right. Let me, for now, just wipe out these two. Remember, we kind of trace about O3 equals O1 and O3 equals O2. I'll redo it, okay? But let's now talk about why typecasting would somehow be necessary very, very often. But I got to do it with caution, okay? So up to now, we got O1 pointing to some C1 objects. O2 points to some C2 objects right here. Very good. And we talk about why each line right here will either compile or not compile depending on the static type, right? I assume you guys will study for that. Please get yourself familiar. And then we got O3 over here, which is the static type object here. So let's remind us again. It doesn't really matter what O3 might be pointing to, either C1 object or C2 object. It doesn't matter. Whenever I talk about O3 dot some method, it will only be determined by its static type, which is objects. That's the principle you want to stick to, all right? But we'll get there. So let's see this line here, okay? So what we have, let me be consistent with the labeling here. We got 1, 2, and 3, right? Let's do that, okay? So here, let me say 1 here, and 2 here, and also 3 here, all right? Let's now see the kind of dilemma we are running into, and then I'll talk about typecasting. Okay? So you can see here, after 1, we declare O3 to be of static type objects, meaning that it's going to point to just null after 1. Okay? After 2, we are actually going to here assign O1 to O3. Right? We're going to store whatever that's stored in O1 into O3. So O3, rather than pointing to here, is going to point to wherever O1 is pointing to. Okay? Let's now pause over here and be clear about what's happening here. Based on what we know, and you guys should know for next week's written test 1, right? We have alias situation. O1 and O3, they point to the same objects. All right? So we got aliases. O1 and also O3. They point to just the same objects after this particular O1 equals O3 execution, right? However, there's a subtle but important difference. Even though O1 and O3 point to the same objects, but because this declared static type is different, O1 was declared to be C1, O3 was declared to be objects. It impacts about what method you can invoke on O1 and O3, even though they point to the same objects. That's the dilemma you have to remember. Okay? So this would mean after this second execution, O3 equals O1, after that, if I say O3.M1, even though O3 is pointing to C1 objects, and C1 indeed has M1, I cannot do it. Just because O3 was declared to be objects, even though you're pointing to C1 objects, you just cannot do it. I'm going to write it down, okay? It's a very important phenomenon. I'm going to mention that a few times, throughout the course, but try to get it, as understood as possible, okay? So O3.M1, right? I'm going to write it down here. Even though O3's dynamic type at the moment is C1, which has M1. O3.M1 is not. O3.M1 fails to compile because O3's static type is objects. As simple as that. The Java compiler for Eclipse or for any IDE, they never try to trace your code, like how we did, like drawing boxes, drawing arrows in order to decide whether a line should compile or not. All right? They only look at static type. Question? Yes.
There's a method inside C1 that's like that's also an object type and like a getter method.
Oh, doesn't matter. You're talking about return type, right?
Yeah.
Okay, doesn't matter. So here we're talking about something. Okay, you were asking about if we have changed maybe M1 here to have maybe return objects. It's not going to change anything. No. The reason that O3.M1 does not compile simply goes like this. Java compiler looks at this dot notation. O3 here was declared in this line with the static type objects. That tells you always you can only invoke the methods declared in objects on O3. So that's why O3.M1, M1 is not declared in objects, M2 is not declared in objects, so you cannot call them. So it's okay? Okay, that's a dilemma. Okay. Now, it's not acceptable because O3 indeed is pointing to C1. We as a programmer, Java allows us, or any OOP allows us to do something to overrule the compiler a bit. All right? The idea goes like this. If this particular reference pointing to C1 with the static type objects is not going to work, why don't I try to create another alias? And that alias is going to have just the static type I will need. That's kind of intuition. Right? So that's something about typecasting. I'll show you, but let's go over definition. So typecasting over here, let me just go back to over there. Typecasting. Okay, he's going to create an expression. And the expression here is really about alias. We're just going to copy the address of the objects into another reference variable. But that reference variable is going to have a different static type. At this point, we don't have to know the exact rules about what kind of a static type can we cast into. But we'll talk about it. There's some rules you got to subject to a little bit later. Okay? Of certain static type. All right? Let's now take a look. Let's now move on. Let's now look at this line carefully. Okay? I will isolate this line. Okay? What this is doing, so you can see O3. First of all, we are trying to create an alias of O3. Simply copy the address that's stored in O3. And then we're going to create an alias with a static type C1. And this entire cast expression will have the static type C1. Once we have done that, we will be able to invoke M1. Okay, so that's kind of the flow. I'm going to write it down, don't worry. I just want to hand wave a little bit, okay? Let's now look at this particular line here, especially right here, okay? You can think about before the dot. You can think about to the left of the dot right here, it is a cast expression, okay? Let me write it down, and then let me put it aside. So star is a cast expression. Or if you want to say it's a typecast expression, that's even better, just more complete. But cast expression is okay, right? And what we have is we got O3, and then we are trying to cast that into C1. And then you can think about the entire expression over here is going to be used as the context objects. That's the structure over here. All right? Let's see what's going to happen at the runtime. What's going to happen is we're just going to create an alias that's going to store the same address as O3. So that means it's going to point to the same object. So we're creating a third one right here. So what we have is, let me put it here. So there's going to be another alias over here pointing to also the C1 objects. But this one here, it will be O3 cast2 C1. Okay? Think about this expression over here has the static type C1. Whatever type you cast into is going to be the static type. Okay? Static type over here is C1. And the most common confusion goes like this. Are we modifying the O3 static type from objects into C1? No, we are not doing it. What we're doing is we create a separate alias, which has nothing to do with O3 anymore. And that alias over there simply copy whatever that's stored in O3 and then make it of static type C1. And then we use it from there. We're not creating any new objects, and we are not really altering the static type for O3. We're not doing them. We just create a new alias so we can invoke the method that we want to. Okay, let me write it down. And this particular alias over here, okay, that's the cast expression. 2 points. Number one, it points to the same objects, points to the same objects as O3 does. You can see here the cast expression points to the same object as O3 does. That's point number one. And point number two, this new alias expression, like you're doing the typecast, has a different expectation. Okay? And number two, has a different static type corresponding to the cast type. To the cast type, which is C1. Okay? So we also say the C1 over here is a cast type. Okay? Cast type. Okay? Over here. Let me repeat one more, and then we can move on. Okay? Our original problem was O1 and O3 both point to C1 objects. However, we can say O1.C1, not a problem. But we cannot say O3.M1. We cannot do that. Simply because the static type of O3, which is object, does not support it. So the idea is, why don't we create another alias right here? And that alias is simply just going to be of static type C1 by using a typecast, just like that. Okay? So after this, if you say O3 cast to C1, and then using the whole typecast expression, say .M1, that'll be okay. Okay? So think about this cast expression right here, okay? The same, identical. Okay? So think about this cast expression has the static type C1, corresponding to the cast type C1. And when you try to call M1, that's okay. M1 is within the expectation of C1. That's okay. However, can I use this, can I use this expression here? I beg your pardon, right here. Okay. Can I use this cast expression over here and say that M2? No, we cannot, because remember the static type here for this expression here is C1. Does C1 support M2? No, it doesn't, right? All right, that's why it will be not compilable. Okay. And of course, when you try to invoke the cast expression over here, .M1, it's just going to call M1. There's only one version. We don't need to worry about multiple versions at this point. Okay. All right, one more, okay, and then we're good. Now we are done with up to here. Okay. Now we're doing number 3. O3 equals O2. All right, let's now reassign O3. Okay. So what we do is over here, let me use maybe how about this gray? Okay. O3 assign O2. Okay. O3 rather than pointing to here, we're going to change its dynamic type. O3 is now going to point to wherever O2 is pointing to, right here. At this point, we know that even though the dynamic type for O3 has changed from C1 to C2, but its static type hasn't changed. So that would mean if I try objects.M2, it's not going to work, right? At this point, we have O3 and also O2. They both point to C2 objects. But if you say O2.M2, that's fine. If you say O3.M2, it's not fine because of the static type object right here for exactly the same reason, right? So that one there, you can write it down, right? It's the same, okay? Let's look at the final casting, okay, and see how we can understand it, okay? Let's look at the final one. C2 here, and also C2 over here. So now we are simply trying to cast O3 into C2. That's what we're doing, okay? Let's now trace it, what's going on. What I will do is, I'm just going to create another alias right here. Another alias right here. And then that one there is basically, I want to cast to C2, especially cast O3 to C2. That's the expression. And that expression there has the static type C2. Static type C2. Or you can think about this expression here, right here, has the static type C2. All right? So now, quick check. Now, if I say this typecast expression .m1 should not compile, right? Because static type is C2, which does not support M1. However, if I say the typecast expression .m2, that will be okay, because C2, the static type, supports that. When you revisit this example here, after today's lecture, you really want to convince yourself these two lines where we got typecast, this compiles, this one doesn't. When we change the typecast expression over here, so rather than casting to C1, we're casting to C2. What used to compile by calling M1 does not compile anymore. What used to fail to compile for calling N2 now compiles, simply because the typecast expression has changed. Okay? Right, this example here, I really try to be thorough, but you can definitely ask me questions, but that's all you need to know for now in order to understand phase number 3 and phase number 4. There are maybe some minor, a small number of rules I can maybe mention in the beginning of Thursday, okay? But after we take your questions, I can now talk about phase number 3 in the remaining time, okay? Question, go ahead.
If we cast it as C2 or C1 without having it explicitly point to C1 or C2, would respective method still work? Actually,
okay. You can think about whenever you try to do typecast right here, right? When I say O3, which is right here, if I say cast that into C2, you can already alter the behavior at the runtime. What it does is it simply just creates an alias that's going to point to the same object as O3 does. And that alias simply got the static type C2. It will be as if you declare this alias over here of static type C2. That's just the behavior. You cannot alter that. Mm-hmm. Yeah. Question?
Just to make sure, for typecasting, we don't have to do the variable assignment, like O3 equals O2. And then...
It's a very good question here. So you can think about for now, once we get to phase number 4, you will see that very often also the typecast expression might be just on the right-hand side of some variable assignment. But I didn't really talk about it to make the example even more complicated. We don't need it. But we'll see that maybe on Thursday. Okay. So the question was, over here, you can see that this one way to really call the method. If I only say O3.M1, it doesn't compile. But if I try to cast O3 into C2 first, and then call the method, if I simply try to cast O3 into C2 first and then call M2, it will compile. So that's okay. Yeah. So there are two ways for you to do it. Either is you don't really store the alias into another variable, or you can store it into a variable and then call the method. Either way is fine. But maybe for today, we'll just focus on this style, just for now.
I think my question came out right.
Yeah.
I was talking about line number 3 and 2.
Okay, that's okay. Yeah.
Before typecasting, we don't have to assign O3 to O1 or O3 to O2, right?
We have to, actually. So the main reason that we want to do cast into C1 or cast into C2 is because, let's revisit, right? It's a good question here. Let's say without doing typecasting, we saw that O3 and also O1, they really point to the same objects. So we shouldn't really accept the fact that we can say O1.M1, but we couldn't say O3.M1. The reason we couldn't really say these two lines and both compile is because of the static type. That's what the Java compiler knows about. So they are not flexible in this manner. So that's why what we're going to do is, given that O1 and also O3, they are both pointing to the same object. So now what we can do is cast O3 into something with the right static type, which is C1. So we can invoke the method.
So before the typecasting, they have both O3 and O1 have to like point to the same object.
Yes, exactly. So before the typecast, you can think about O1 and O3. They both point to the same object. However, their expectation are different because of the static type. Yes, very good. Yeah, so the remarks I'm just mentioning, I believe they will appear in the digest. So you can definitely check it out, right? Just in case you don't have time to write it down. Okay. So don't be too terrified. I think this example here is not too bad. I try to restrict it in a way so we can at least see a first example about all the three concepts. But once we get to inheritance, starting from next week, we definitely will see more and more like a general pattern. That's something you guys will have to know how to deal with. But one step at a time. Okay. We've got about 15 minutes. I would suggest the following. I do have some general rules about variable assignments and also the compilation. I'll leave them to Thursday in the beginning. We can also do a little bit of recap. Why don't we move on to phase number 3? Okay, let's at least finish one phase. Okay. Okay. I'll change the template file accordingly a little bit later today. Okay. Let's now move on to phase number 3. At least finish one. Okay. So now we look at phase number 3. Okay. Which is right here using the get class. And let's remind ourselves. The get class over here, okay, I'll put a star. The get class returns the dynamic type of the context objects. All right, that's what you would do, okay? We'll do some tracing in a moment. Let's look at the definition first. And also notice one thing here. If we are able to get to phase number 3, that means we didn't really return in phase number 1 or phase number 2, right? So you make sure you study for phase number 1 and 2. It's going to be covered for the test next Monday, right? So that means the if condition here, this equals obj must be false. Otherwise, we would have returned. And also, obj equals null, the second phase should be false as well, right? So think about these two expressions. This equals obj, and obj equals null. They should both be false. Let's put it another way. If they are false, that means their negation must be true, right? So let's put it here. So I know two things before, if I can reach phase number 3. This must not be equal to obj. They are different objects. And also, from phase number 2, I also know that the obj I'm trying to compare with, it is not equal to null. Otherwise, I would have returned false. Right? So these two Boolean conditions kind of tells you that if you're able to move on to phase number 3, that means we have not returned just yet from the previous two phases. Right? Yeah, you can, if you got any trouble understanding this logically, reach out to me. We can talk, right? It's not that difficult, okay? And then we're going to look at just this part over here, get class, right? So you can see we got two get class expression, okay? Get class. And get class right here, okay? It's going to return the dynamic type. It's going to return the dynamic types of the context and parameter objects. Okay, you can see obj right here is the parameter obj. And also this, of course, is the current objects, right? Whatever context object we are calling the equals method, right? So these two. We're comparing their dynamic type. And what are we saying? If their dynamic types are different, return false. Put it in a, I'm not sure if that's appropriate. You can say we cannot compare apple with banana. Right? If you're comparing two objects whose types are simply different, we just don't compare them. Just the definition. Okay, let's visualize this a little bit. Okay? So what we have is, we got the current object this. We got a parameter object obj. And this is pointing to some objects at a runtime. And obj is also pointing to some objects at a runtime. Since we know that this cannot be null, and also obj is also not null. We know that, right? And we also talk about dynamic type. It's going to be whatever the title it is. Let's say triangle. Just make it symbolic, okay? And think about obj here. The dynamic type could be maybe a star. Okay, sorry. Okay, dynamic type. Okay. So think about this star here will be obj.getClass. And also this triangle here will be this dot getClass. Each one of them is simply going to return what's the type of objects these two references are currently pointing to. If they are pointing to the objects of different types, we don't even compare them, just return false. If they are the same type, then we bother to go to phase number 4. That's the logic. Okay? Okay, let me just see if there's anything else on my notes. Okay, let me write it down here. Okay, right here. Return false. Objects with different dynamic types are trivially not equal to each other. Trivially in the sense that you don't need to go with any more code execution. You know, if they are apple versus banana, I don't compare them. I resist to compare them. Trivially not equal to each other. Okay? Yep, I don't need this. All right? So that's about the design for phase number 3. Why don't we look at some tracing? If time permits, I can talk a little bit about phase number 4, and then we're good. Okay? Okay. Now, I'll give you a little bit of time, actually, before Thursday to really look at this example maybe a little bit more closely, right? You really want to get it clear. Okay? Okay, let's look at some tracing for phase number 3. Okay? Right here. Okay, for that one there, let's now also revisit about the idea of callback value, right? Remember that, right? It's also very important, okay? Let's say we are tracing line number 9, right here. Okay, so we try to do system.out.println, and then we say p1 equals s. All right, let's see where p1 is. P1 is right here. And S is just a string. So think about dynamically, S is just of string type. Okay? And for P1, dynamically, it's a point v2, right? So in this example here, the static type for P1 is point v2. Dynamic type, also point v2, which is okay. Okay? So let's now write down what we know already. So P1 has the static type point v2. And then it's now going to assign to a new point v2 objects, 2 and 3. So think about the point v2 over here. It would be the dynamic type of P1. So which means if you say P1.getClass, it should give you point v2. Right? We can look ahead like that. Okay? And also we got the string S right here. Okay? So think about we got S over here. Let's draw a box, right? Just to show that. S dynamically is pointing to a string objects. Right here. Okay, don't worry about the attributes. It might be some array of characters, etc. We don't need to worry, right? Dynamically is a string. Okay? So think about the string over here. So this is the dynamic type of S, right? Consistent with what we said, right, in the example. Okay? And let's now try to evaluate when we say P1 equals S. Okay? P1 will be the context objects. That means every occurrence of P1. So every occurrence of this is going to be replaced by P1. Okay? So when we try to trace it in this equals method here, every occurrence of this will be just P1. Okay? So think about here will be P1. And also this and this, that'll be phase number 4. I'll just write it down anyway. Okay? Well, another way to think about it is this is simply just pointing to P1. That's another way to think of it. Right? This is pointing to wherever P1 is pointing to. So P1 is where we make the method call. And this is how we trace the method, and that's the context objects. Okay? And then let's look at OBJ. OBJ over here is actually call by value. Right? Let's now recall. Can anybody try? Oh, that's covered next Monday, right? Call by value. In this case, we are making the method call in line number 9. P1 s. What will be that implicit variable assignments that will be executed using call by value? Just tell me that particular variable assignments. What would that be? Let me repeat my question, right? Just in case that's not clear. We have this method call, P1 s. It's a method call, so there will be a call by value, which should correspond to the method declaration equals right here. Okay? What will be that call by value variable assignment? Go ahead.
OBJ equals S.
Yeah, exactly. Parameter equals argument, right? Okay? Yeah, just make sure you guys know about it. Okay? Let's write it down. So that means all the way to right here. Yes. Okay? So call by value tells us it's going to be OBJ equals S. So that means the OBJ, the parameter is pointing to right here. All right? And if we try to execute a trace, P1 equals OBJ. P1 and OBJ, their addresses are different, so they cannot be the same. Right? So this will be false. And also OBJ equals null. Apparently, it is pointing to some string object, so cannot be null. Also bypass. And when we get to this line right here, right? Let's look at them individually. If I say P1.getClass, 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 it should be point v2. Versus, if I say obj.getClass, that will be parameter obj.getClass, it should be string. And when you compare these two dynamic types, just string comparison, right? But it's not exactly a string, but when you look at that on the tracing paper, these two classes are simply not the same class. True. Return false. They are not equal to each other. Okay? So what we have is point v2 not equal to the string. That would be true. That's why we're just going to return false. Once we return false, the rest, which will be phase number 4, will be bypassed. Okay. Are we good? Okay. I think we got 2 minutes. We can do a little bit. Okay. I think it's nice to do a little bit of warm up for phase number 4. Okay. Yeah, of course you can.
What's the static type for the S string?
Oh, static type? Oh, good question. Yeah. All you got to do is look at the S over here. The declared type is exactly string right here. Yeah. Just happen to be the same. It's a string as a static type. At the same time, it's a string object. Even though we don't really say new string, but whenever you use a string literal expression, it's going to create a string object behind the scene. Yeah. Question?
Why the pointer v2 is a static?
Okay, mean a P1?
Pointer v2.
Point V2. Okay, static type, right? Because, okay, you were asking why for P1 the static type is point V2, right? So look at P1 here. To figure out the static type, look at where it is declared. It's declared here, it's point V2. That's your question, right? Okay. Okay, guys, I'll pause here. I don't think I should really move on anymore. Any questions about today? We have some minutes.
I know we haven't got into phase 4, but
Yeah.
Just by looking at the code, my question was if the parameters like x and y, if they're like string values, would we still use equals for their comparison or not?
Let's maybe talk about this maybe on Thursday. I think that'll be more appropriate. Okay, yeah. Okay, one more remark, and then we're done. Okay, one more. Okay. Now, what you can think about is right here. If you look at phase number 4, you got everything you know in order to understand phase number 4. Thinking this way, you can see that we actually got some typecasting. We cast from OBJ to point V2 so that we can say like a .x, .y. So this is a question you can ask yourself. Let's say, hypothetically, I don't have this cast. Rather than saying other, let me say OBJ. Can I say obj.x and obj.y? Would it compile? In order to judge that, we should look at the static type of obj, which is objects. Object does not have x and y. It's only for point V1 or point V2. All right, that's something we'll revisit a bit on Thursday. All right, thank you so much. And then I'll reach out to you guys about the extra hour, most likely Friday, but I'll confirm. All right, thank you.